Hello all, welcome to the Solocast of Firecode Tech. In these episodes, it's just going to be me, your host, Gus Gagliardi. There's going to be a range of topics, but I'm going to talk about specific technologies, installation standards, codes and how they work, as well as some other interesting topics that don't neatly fit inside of the context of a normal interview. Hello all, welcome to Firecode Tech episode 26 of the Solocast series. Today we're talking about smoke control systems. In our continued pursuit to detail every aspect of fire protection engineering, today we're talking about smoke control, which is a rather difficult topic. On today's episode, I want to answer questions like, what are some critical definitions in smoke control? What kind of spaces and occupancies are smoke control systems required? And what kind of codes and standards do we have around the topic of smoke control? Do me a big favor and subscribe so you never miss an episode, and give me a follow on social media. I promise I'll post about some neat fire protection subjects. Oh, and if you could, give us a rate and review on Apple Podcasts. Alright, enough of that. Let's get into the episode. To frame our discussion today, I just want to say that I don't have a tremendous amount of experience with smoke control systems, really, just how to avoid them mostly. There are engineers and firms that specialize in these kind of systems because of their complexity and difficulty. If you finish this episode and you're still confused, that's okay. I'm going to drop a couple links to some interesting articles that detail these systems more completely. So let's get started with some definitions around smoke control systems. What is a smoke control system? Well, broadly, there are two types of smoke control systems: smoke containment systems and smoke management systems. Let's start off with smoke containment. Smoke containment is defined in Nfpa 92, the standard for smoke control systems, as a smoke control method that uses mechanical equipment to produce pressure differences across a smoke barrier. The smoke containment category contains systems that include stairwell pressurization, elevator pressurization, zone pressurization, and vestibule pressurization, and area of refuge pressurization. So as you can see here, the common theme is pressure differential across the smoke barrier or the intended smoke-proof membrane. The second major category of smoke control system is smoke management systems. A smoke management system is described in Nfpa 92 as a smoke control method that utilizes natural or mechanical systems to maintain a tenable environment in the means of egress from a large volume space, or to control and reduce the migration of smoke between the fire area and communicating spaces. A quick caveat that smoke control systems are not smoke and heat removal systems like you would see in warehouses where they have smoke and heat venting. So let's talk about what occupancies and spaces might require these systems, since we framed the discussion with what are the different types of smoke control systems. The IBC has specific provisions in Chapter 4 which dictate certain occupancies and/or spaces that require smoke control systems. There are some similarities and differences from occupancies that adopt the International Building Code or the Nfpa codes and standards, so you need to understand which one the jurisdiction you're working in has adopted. The majority of the discussion today will be centered around the International Building Code approach. It will provide value and insight even if you are working in an occupancy that has Nfpa required smoke control systems. So Chapter 4, Section 403, 404, and 405 have specific building features that may require a smoke control system. These chapters respectively are high-rise, atria, and underground buildings. So let's go through these each in specific. High-rise building is a building that, from fire department access, exceeds 75 feet as defined in the International Building Code. So there are a couple different situations in Section 403 that might require a smoke control system. Specifically, these spaces that are common to have smoke containment systems are the elevators and stairways in high-rise buildings. There's an option to provide a smoke-proof barrier or a smoke barrier as defined in Nfpa 92, but sometimes in lieu of the smoke barrier, it is chosen by the design professionals to utilize a smoke control system. Let's move on to atria. This is one of those things, and if you haven't looked at it, I'd recommend you go take a look in Chapter 2 of the International Building Code. There are some definitions in here that require when you have to implement big sweeping changes for fire protection systems. Atria and high-rise are two of those definitions that have huge impacts on building design. So the definition of atrium is in Chapter 2, and it states an opening connecting two or more stories other than an enclosed stairway, elevators, hoistways, escalators, plumbing, electrical, air conditioning, or other equipment which is closed at the top and not defined as a mall. Stories used as this definition do not include balconies within assembly groups or mezzanines that comply with Section 505. So the important part of this definition is the connecting two or more stories. So think of, a grand entrance to a building might have an atrium. So if you take a look at Chapter 4, Section 404 for atriums, you can find the specific provision that requires a smoke control system after you've determined you have an atria. So 404.5 smoke control systems shall be installed in accordance with Section 909, which is the chapter in IBC, Chapter 9, Section 909, smoke control systems, that talks about the specific details of the requirements for that system. There's an exception here. It states, in other than Group I2 and I1, Condition 2, smoke control is not required for atriums that connect only two stories. So there's a small exception for occupancies other than institutional occupancies. Moving on, Section 405.1, which is the underground buildings requirement. So in Section 405, it describes what kind of underground structure would require a smoke control system. 405.1 general states the provisions of 405.2 through 405.9 apply to building spaces having a floor level used for human occupancy more than 30 feet below the finished floor of the lowest level of exit discharge. So this is a similar requirement to high-rise buildings in which the measurement is based on the level of exit discharge. So in a high-rise building, it's fire department access, and then for underground buildings, it's level of exit discharge. So we've paired a fire and life safety feature with a building dimension. In this case, it's 30 feet below grade, or 30 feet below the lowest level of exit discharge. I want to speak briefly about Nfpa 92, which is the standard for smoke control. So Nfpa 92 is important because it details the calculation means and methods as well as some of the component architecture that is common for smoke control systems. Like we talked about before, there are a number of ways to design smoke control systems, so it's a bit more open-ended than some systems in fire protection engineering. Smoke control system is a giant integrated system. That is, the fire alarm system is integrated with the HVAC system in order to create a tenable environment or to pressurize a space. The standard details not only critical definitions and calculation procedures, but also the important documentation and testing applications that are common to smoke control systems and very complex. So, as another note, many jurisdictions have additional provisions for documentation and testing required for smoke control systems. For instance, the state of Oklahoma has a detailed procedure for what is required for new smoke control systems, documentation, calculations, engineering reports, and so the documentation and commissioning / testing of these systems can be substantial. So that is another good reason why these systems should be avoided if possible. The cost of these HVAC units and the substantial added fire alarm system component architecture is quite a cost add. So if possible, and you can avoid an active smoke control system, generally architects and owners will like to. Another reason for the importance of documentation for these systems is that fire protection engineering documentation can be exceedingly hard to come by for existing facilities, and these are very complicated systems that require oftentimes large amounts of makeup air coming from potentially unconventional places like windows or doors that open on fire alarm signal. So if you don't have detailed documentation of the specific sequence of operation and what is required to happen when the system engages, it can be dang near impossible to figure that out retrospectively for a facility when you're going to modify an existing smoke control system in the future. Here's a list of some of the documentation required in Nfpa 92, the 2021 edition. This is in Chapter 7, more specifically 7.2. This section is called Detailed Design Report. So in 7.2.2, this section describes what features are required in the design report that you need to have as a deliverable for the creation of this system. And this is a bit of a strange system because there's a lot more interface than usual in between the FPE and the contractor installing. It's kind of a joint procedure to develop this report. So some of these components of the report are the system purpose, the design objectives, design approach, building assumptions, location of the smoke zones, some of the critical factors like pressure differences, fan and duct specifications, calculations, damper specs, inlet or exhaust size information, detailed method of activation, smoke control system, logic or operation, and how the system is going to be commissioned. So this is kind of a full life cycle analysis of this fire and life safety system. And you can tell by the detailed nature of this report that it is a substantial amount of work to complete one of these reports. I think that's going to wrap it up for this episode on smoke control. We'll readdress this topic in the future, and maybe I can get somebody on the pod who can address more specifically calculations and some of the performance-based engineering that is common for these systems. Thanks for listening, everybody. Be sure to share the episode with a friend if you enjoyed it. Don't forget that fire protection and life safety is serious business. The views and opinions expressed on this podcast are by no means a professional consultation or a codes and standards interpretation. Be sure to contact a licensed professional if you are getting involved with fire protection and or life safety. Thanks again, and we'll see you next time.